Hi guys, today we will discuss about polar coordinate system. So as you all know, there are several coordinate systems which we come across in our academics. Those are Cartesian, polar coordinate systems, and Cartesian. As we all know, polar and Cartesian coordinates are in 2D, whereas cylindrical and spherical coordinate systems are in 3D. So let me get into the content of this presentation. So let me first draw um, I'll just draw the XY lines first, then I'll just mark a point A. Okay, so in Cartesian coordinate system, you can mention this as A XY, X comma Y. Okay, so what about how will we define this point A in a polar coordinate system? So we need the radius R. So let me just tell you that this is the centroid. Okay, 0 0. So I'll just draw a line originating from the origin and ending at point A. So that is R. That is the radius. Okay, that is the distance, and I mention it by R. Whereas the angle made by this line with the x-axis is called theta. Okay, and here, as you can see, as I have mentioned here, the direction of increasing R is defined by ER. Okay, so that is the unit vector. And the direction of increasing theta, so how, in which direction will it increase? In this direction, isn't it? In this direction. So I just mention it as E theta cap. ER and E theta make a 90-degree angle. That's why we have mentioned orthogonal unit vector. Okay, so ER cap and E theta cap. Cap is just to mention that they are unit vectors. Unit vectors in the sense the magnitude is equal to 1. So, so I'll just read it, which I have pointed out here. In polar coordinate system, the position of a particle A is determined by the value of the radial distance to the origin R, and the angle that the radial line makes with the arbitrary fixed line, as I have mentioned. And the trajectory of a particle will be determined, as we know, the r and theta as a function of t. So just consider, we are considering a time varying phenomenon, and the variable is the position. So how can we define the position with x and y coordinates, considering the 2D problem, x and y coordinates, or radius and theta, as we have mentioned. So let me go to the next slide. So here I have just moved this point A from here to A dash. Okay, so this is the new point. This was the old point, this was the new point. So I have just moved this from here to here. So that was the path which followed. Okay, so here the position vector of a particle has a magnitude equal to the radial distance and a direction determined by ER. So as I have mentioned, this is the continuation from the previous slide. So the A can be um, written as the vector A. Okay, now it's a vector. Since it is existing in a two-dimensional plane, we can describe this point A as R E R cap plus theta E theta cap. Okay, so that is the definition. So in the polar coordinate system, and what else we have to write? Yes, so what I was telling was A is moving from A to A cap, A dash, sorry, A dash. So next, our next motive is we need to just consider it's a time varying phenomenon. Okay, so what about we find the velocity and the acceleration? So in order to find velocity and acceleration, we need what do we need? We need to differentiate with the time. Okay, so we need to quantify it. There has to be, like, we have to know how much it changes. How can we define this change in magnitude as well as change in direction? So we can't just define this a dash with the change in magnitude. We need to know the change in direction. So let's see. So RER cap. Okay, as I mentioned, A is defined as RER cap plus theta e theta cap. Okay, so let's see here. uh, so we know that the vectors er and e theta does not change with the change when the coordinate r changes. Just consider, you are just varying this a from here to here, keeping the theta constant. Okay, so do you think that the vector er and e theta will change? Just see, here this is a and here this is a dash. Okay, theta remains the same. So this is er, previously er cap. Now I make a point er, sorry, er, the new er. Okay, the new er, I'll just mention er dash cap. So here it was e theta cap. Okay, now this is the new e theta cap. Okay, but you can see they are parallel, so the parallel unit vectors doesn't make any difference. Okay, they are parallel, so they will have the same sense. So that's what it says. The vectors er and e theta do not change when the coordinate r changes. So what will happen if the theta changes? That's what here. The theta is varying from theta to theta plus d theta. So you can see here a is moving from, sorry, the point is moving from a to a dash. So the angle is varying from theta to d theta, theta plus d theta. Okay, so we have to know how to quantify this change in direction. Okay, change in the direction in the sense change in the vectors, how the vector er and e theta will vary. Hmm? The new er and e theta. So I'll just make sorry, pens. Okay, I will draw um, a dash. Okay, for your understanding. So now this was the previous point, this is the new point. Okay, so theta is varied from theta to theta plus d theta. Okay, this was theta and this is new, the new um, position is denoted by the angle theta plus d theta. Okay, this was r, this is r dash. Okay, so a dash is equal to r dash e r dash cap. Okay, this is er dash cap, er dash cap. This is e theta dash cap. Okay, okay, I hope it is clear to you. So we want to know what is this okay, so we want to know what are these we know r dash and theta plus d theta. Okay, consider we know these magnitudes. These are magnitudes, and er dash cap and e theta dash cap, they are the new vectors. Okay, the new directions. Okay, so we only know er and e theta, they were the previous. So I'll just bring your attention to the previous slide here. So here you can see er e theta, er plus der, e theta plus d theta. So they, I mean, as I have mentioned here, like I mentioned it with er dash. So consider er dash is equal to er plus der. Okay, and e theta dash is equal to e theta plus d e theta. Okay, So that's it. Hmm. So what are we going to do? So this is actually a vector addition. Okay. So I hope that is clear to you. Hmm? Okay. So what we are going to do? We are going to find a relation between ER and d theta. So we know this d theta value, okay, and we are going to find the relation between de theta and d der. That's what it is here. The difference, between er dash and er, okay, and we know d theta. Okay, but there is some quantity over here, so we have to find that quantity. So in order to find that, what I will do, I'll just change the color to make it more easier. I'll just make a new slide over here. Okay, so we need to find out that unknown quantity der is equal to d theta. So I'll just bring this. Okay, so just consider this a and a dash. So there was this point a dash over here, so they just consider they were over imposed. Okay, so we will get a figure something like this. So e theta, e dash theta, I'm just exaggerating this d theta. So er dash, e theta dash, or e theta plus d theta, or er dash, or er plus der. Okay, so these are like basically vector additions. Okay, not they are vectors, so they have to be treated as vectors. So sorry, this is a scalar quantity. This is a scalar quantity. Okay, so I will bring the same figure to the previous slide, sorry, the new slide. So here we have got er dash, e theta dash, e theta. Okay, and we know this is d theta. And as we know that this is perpendicular to this and this is perpendicular to this also becomes d theta. Okay, fine, that is perfectly fine. Okay, so what else you are going to do? We know one thing. What do we know? um we know this vector addition. Okay, what we are going to do is der. So we know that er dash is equal to er plus der. Okay, so this is basically vector addition as I mentioned. So this is er dash, this is er, okay, and this is the d theta. What will, so we just mentioned this unknown stuff. Okay, and the magnitude is d theta. So what do we multiply with? We multiply with e theta, because the e theta will provide us the direction, sense of this vector. D theta is a scalar quantity as I mentioned, so e theta will provide us the sense. So this is actually basically like you will actually understand from the figure itself. It's not a big deal. So this is er plus der. Okay, this is er, this is the vector, unknown vector, which is having the magnitude of d theta, and we, as we know, this is the e theta, the non vector. So we multiply it with it and we come to a come to the notion that DER is equal to d theta E theta. Hmm? So that's it for the first lecture. So what are we right now? We are at DER is equal to E theta d theta. So I hope you enjoyed this lecture. I wish if you could just go through your basics of Cartesian and polar coordinates, you will understand more. So the only thing is you just have to differentiate between scalar quantities and vector quantities, and make sure you know the difference of vector and scalar. So I hope you enjoyed. Thank you very much.